Good afternoon, everyone. Welcome to AWS Data Insights Day. My name is Saurav Das, and I'm a Senior Product Manager at Amazon Redshift. I'm going to do a deep dive into reliability features in Amazon Redshift. We have a lot of content to cover, so let's get started. As you all know, tens and thousands of customers use Amazon Redshift every day to run data warehousing and analytics in the cloud. And these customers process exabytes of data for business insights. Amazon Redshift is a fully managed petabyte-scale data warehouse in the cloud, which was introduced in 2012 and has been continuously innovating since then. Amazon Redshift helps you securely ingest, combine, share data, and run analytics in just a few clicks with minimal data movement or copying. The primary goal here is to derive valuable insights to make decisions based on data. There are four big areas of investments that drive benefits for our customers to help them achieve their business goals, as shown here. This session is going to focus on industry-leading reliability features that are available to you at no cost. So, as you all know, today in this new data-centric world, everyone is a data user. Given the strategic importance of data, analytical workloads are becoming increasingly mission-critical in nature. Thus, any downtime leads to business loss. And that is why we are seeing a trend where customers are running these analytical systems 24/7 now. Some example use cases of mission-critical workloads are financial institutions analyzing customer data to detect fraudulent activity, or healthcare providers analyzing patient data to identify risk factors for chronic diseases, and the list goes on from there. Due to these use cases, availability and reliability is very, very important for a modern data warehouse. So before we dive into reliability features in Redshift, let's start by talking about some of our existing customer use cases. Janssen Pharmaceutical is a company owned by Johnson & Johnson, and Janssen has been a long-time Amazon Redshift user like many other customers. Like other customers, Janssen also derives critical business insights on a daily basis to make important business decisions, and these decisions are used or sometimes made by the team of data scientists, data stewards, business users, and external users as well. Over the past 2 years, we've seen healthcare and life sciences companies such as Johnson & Johnson ramping up their analytical capabilities to support their drug research and accelerate their fight against COVID. Amazon Redshift is at the heart of this process, and it needs to be highly available because any disruption delays critical business insights. You can see why availability is so important here. Let's take another example. You heard from Stripe earlier today about how they are using Amazon Redshift to power Stripe data pipeline. Stripe's customers have been requesting a highly available and reliable integrated analytics solution that can operate at scale. Stripe data pipeline is the answer because it's an easy no-code solution that allows these customers to access all Stripe data in Amazon Redshift. Now, I hope with these two customer use cases, I've made a strong case for why reliability and availability is so important for your data warehouse. Amazon Redshift customers today already enjoy best-in-class security, compliance, and reliability features out of the box at no additional cost. So let's dive in and talk about some of these reliability features. First up, Amazon Redshift is a highly available, resilient cloud data warehouse. We support 99.9% SLA, which is ideal for most business-critical applications. Redshift also has the ability to automatically recover from most software, hardware, and network failures. These are built-in reliability features that are transparent to the user, that automatically kick in as needed, and there's no manual intervention needed. Redshift Managed Storage, or RMS as we call it, has also been a game changer for our customers. It allows customers to automatically scale data warehouse storage capacity without adding any additional compute resources, and this is applicable for both RA3 and serverless workloads. The storage system automatically manages the cache to deliver high performance equivalent to a local SSD. RA3 instances also feature high bandwidth networking that reduces the time for data to be offloaded and retrieved from S3. So now you pay the same low prices for SSD and S3 storage, and you can scale storage capacity of your data warehouse without adding and paying for additional instances. Since data is stored in Redshift managed storage, which is backed by Amazon S3, there is no data loss, and it is highly available and durable by default. RMS also automatically replicates data to all availability zones within an AWS region. Amazon Redshift also offers automated snapshots for provisioned clusters and recovery points for serverless. These are offered at no charge but have limited retention period. Customers also have the option of paid user snapshots that can be retained indefinitely. For disaster recovery purposes, customers can also choose to replicate these snapshots to another AWS region of their choice. For data recovery or to create copies of data, customers can recover from these snapshots on demand, either at the cluster level or at the table level. Although these snapshots are a great way to recover your data, but this approach may require application changes as the endpoint changes for a recovered cluster. For such customers, cluster recovery across AZs is a great option. Customers can relocate a cluster in another AZ without losing any data or having to change their client applications. As existing cluster fails over, a new cluster is created on demand in another AZ. This feature is offered at no additional charge since the cluster is created on demand and only one cluster is running at a time. The cluster's endpoint remains the same after relocation occurs, and the applications can continue operating without any modifications. This feature is opt-in for RA3 instance family, but is enabled by default for serverless workloads. Redshift managed storage also ensures RPO 0 with no data loss. As you can see, Amazon Redshift supports many recovery capabilities, such as automatic remediation of software, hardware failures, and network failures, automatic backups to recover your data, and the ability to relocate a cluster to another availability zone without making changes to the application. However, since data warehouse workloads are becoming mission critical, as discussed earlier, our customers demand higher availability and even lower RTOs, that is within seconds, to avoid any downtime. To meet the demands of such mission critical workloads, we introduce multi-AZ deployments, which is in preview, and we've received some great feedback from customers such as yourself. Multi-AZ deployments for provisioned RA3 clusters support running your data warehouse simultaneously in multiple availability zones and continue operating in unforeseen failure scenarios. Multi-AZ is intended for customers who have mission-critical analytics workloads that require the highest levels of availability and resiliency to an AZ or infrastructure failure. Multi-AZ deployments reduce recovery time to seconds, typically under a minute, by automatically failing over your data warehouse to another AZ in the unlikely event of an AZ or infrastructure failure. RPO is 0 as it is backed by RMS. Since multi-AZ is managed as a single data warehouse with one endpoint, it can maximize query throughput by using compute resources from both AZs, and there are no applications changes needed to maintain business continuity. That is even when a failover occurs. So let's briefly talk about how multi-AZ reduces recovery time during an AZ or infrastructure failure. On your left is a multi-AZ cluster with 4 nodes signified by the blue dots in each AZ, AZ1 and AZ2. AZ1 being primary AZ and AZ2 being secondary AZ. The The cluster has a total of 8 nodes that are all part of the data warehouse sitting behind a single cluster endpoint. The compute from all these 8 nodes gets used at all time as these queries are routed to each AZ in a round-robin fashion. Let's say you experience an unlikely event such as an AZ failure on AZ1. When this happens, your multi-AZ cluster will fail over to AZ2 automatically, which is the new primary AZ. During the failover process, all active connections on AZ1 will be dropped and any in-flight connections will be aborted. New connections can be resubmitted immediately and will be routed to a healthy AZ in AZ, that is AZ2, within a few seconds, typically under a minute. Additional compute nodes will also be provisioned in AZ3 to always maintain posture in 2 AZs. The key thing to note here is the reduced recovery time and that the capacity is guaranteed as it is pre-provisioned. There are no duplicate storage costs as storage is shared. You incur additional compute charges only for the compute that is being actively used and not sitting idle as a standby resource. Now, for the fun stuff. I'm going to show you how to create a multi-AZ cluster and its various features, and we are also going to simulate an infrastructure failure and measure recovery time. Okay, so now for the fun stuff, as I said, let's create a preview cluster, which is multi-AZ. I'm just going to name it something friendly enough. And then out there, you're going to select your preview track, and then you're going to choose your instance type. And then also you're going to select multi-AZ deployment option as yes. You're going to see the configuration summary is getting changed automatically, showing you the real-time costs. As you scroll down, there are a few other options, which I think you can load sample data if you want that, and you can set a password or skip it. And then don't forget to turn on encryption, because multi-AZ clusters need to be encrypted. That's a requirement and a prerequisite. And then off you go, and you can create your multi-AZ cluster. Fairly simple, isn't it? Now, I already have, this is going to take some time. You can see there are messages being displayed. The cluster is getting created, but I have the cluster created here already. Also, this summary page also has a lot of good information. You can see there's a single AZ cluster. There's an availability zone column, which actually tells you about which AZs your cluster is running on. There's a flag column, which distinguishes between single AZ and multi-AZ. And then, you can see snapshots there. You can even restore from a single AZ snapshot and create this cluster, and you'll see the same create page. Now, let's go into one of those existing clusters, which I already have. You have some general information, which was also there in the summary page. You can go into the properties tab, which again tells you the AZ information if you couldn't find it in the previous page. If you scroll down below, I think you're going to see node information and IP addresses. So I think, let me just find it. Okay, it's down below over here. You're going to see the node information and the IP addresses. You can see both the compute nodes in the primary AZ and the secondary AZ over there. Right? Now, what we are going to do is we're going to try and simulate a failover here, right? So for that, I think, right over here in the actions button, you can see there are multiple other options. This is similar to single AZ. We have a button there which says failover primary compute. In your preview build, you're going to see inject failure. The failover primary compute does the same thing, but you're going to see these new changes reflect in your preview build pretty soon. Now, I have a timer here. And I have 2 terminal windows to connect directly to the cluster. So first, what I'm going to do is I'm going to use one of the terminal windows. I'm going to get onto an EC2 instance, which is actually I'm already on an EC2 instance. So I'm going to connect directly to the cluster. So I need to refresh the endpoint. So I'm going to copy the endpoint and let's see. Okay, so the endpoint's already there. So now I'm going to log in, enter the password, and I'm going to look for the different tables which are available. As part of this, I think I feel like I should go into the category table and see what does it look like? So let's go check out the category table. Okay, so it has a few columns. We're going to run a very simple query, which is we're going to do counter star on the category table. So let's see what it tells us. So this is a very small table. It has 11 rows, right? So now what I'm going to do is I'm going to trigger a failover of this multi-AZ cluster. So first off, I'm going to go to failover primary compute, and I click that. It's going to pop a warning like you see for inject failure today, right? So it's the same thing, and it's telling you what it's trying to do. And once I say continue, I'm going to start the timer. And you're going to see messages on top which are informing you what's going on behind the scenes right now. Now, I'm going to try and query into the cluster right now, and let's see what happens. So till when does it take to actually break the connection? So, so this is in progress right now, and you're going to see right at this point that the connection is going to break, right? So now what I'm going to do is it's hung, so I'm going to try and connect again to this cluster by using the same connection string. And it says that the cluster is restarting, right? So we have 43 seconds on the clock. Now let's go ahead and try again. And you can see that within under a minute, I'm able to connect into the cluster. I'm going to try and run the same query again. And you can see that this query is going to succeed, right? Okay, voila. So that's it for our demo. Thank you, everyone. So now, once we're done with the demo, for next steps, if you're already using Redshift, I encourage you to check in with your account team to continue to learn more about what's new and make sure you're taking advantage of all the latest features. You can also follow us on LinkedIn and get updates on new features and content. Also, definitely check in with your account team for a free optimization session and avail those free credits to try out Redshift serverless. If you're just getting started with Redshift, I encourage you to ask your account team for a 10-minute demo and to visit the playbook in our documentation to learn more about starting a proof of concept. You should also check out the blog about multi-AZ on AWS Big Data blog as linked here. And if you aren't sure who to reach out to, you can request help from AWS with the link on the screen. With that, thank you, and have a great day.